So this week we're going to complete the phytochemicals, and we're focusing primarily on alkaloids. Also, some other sulfur-containing compounds get a couple slides as well. And then that will complete all the material we need to know for the exam, or you guys need to know for the exam. If you guys have any specific questions, let me know. I'll post those exam review questions for you that I really recommend you guys go through. And I tried my best to break down the 73 questions for the midterm exam fairly between the different lectures. So a little bit on history, a little bit on the pharmacology on the intro lectures, and then the phytochemicals. Each section got its own group of questions. The exam will be fair. I think most people do well, but it requires you to learn the information, okay? So, alkaloids. Alkaloids are a really interesting group of compounds. One thing with alkaloids is some of the most potent drugs and powerful drugs that exist are alkaloid-based. And what an alkaloid is a compound that contains a nitrogen, usually in a ring structure. There's some alkaloid-like structures that aren't technically in a ring structure, but most of them are in a ring-like structure, okay? And one thing that you know about nitrogen molecules is that all proteins contain nitrogen molecules because amino acids are made of an amino group. But also, most of the neurotransmitters that you have in your body, I think most, I think all the main ones all contain a nitrogen group in it. So it's not surprising that a lot of these alkaloids have the potential to interact with the nervous system. And some of the alkaloid compounds are very, very powerful drugs. You know, a lot of the phenolic compounds we talked about are things that you would find in your diet in hopefully relatively high amounts, and a lot of them are considered non-essential nutrients. A lot of these alkaloids are not typically found in your diet. There's some of these guys you would find, but most of them, no, you wouldn't. And they have a very specific pharmacological effect, okay? So we'll go through these and explain a little bit about the nervous system as well as we go through a quick little review for you guys. So when we talk about the nervous system, because so many alkaloids affect the nervous system, we'll just review it really quickly, okay? Now, in the nervous system, you basically have nerves that are constantly being stimulated and inhibited by other nerves that basically affects the action potential when these guys discharge. And when a nerve discharges, it sends a vesicle of neurotransmitters to the edge of this nerve, and it basically spills these out, and then they bind to various receptors in the body. And because of that, there's a number of different places that a drug or a compound or a phytochemical or whatever you want to call it can affect these nerves in the nervous system. And so there's a lot of herbs. Some herbs I'm not talking about that I could include in the nervous system section, but most of the compounds we're going to talk about are alkaloids, okay? And so you can affect the inhibitory, the excitatory nerves. You can affect the ion-gated channels along the side of the nerve to basically block these ion-gated channels open so that the nerves are constantly firing, or block them shut so they can't fire, and that would cause like paralysis and like would act as a nerve block. You can affect the reuptake of certain neurotransmitters in the body that would increase the effects of the neurotransmitters, or if you block the storage of them, it would break them down so that you'd have less of an effect associated with that. Some of the phytochemicals and drugs can bind directly to the various receptors that are on target cells like muscles or other nerves or whatever it may be, and exert a similar effect that the neurotransmitter might have. And then they can also target some of the enzymes that are involved with degrading or breaking down neurotransmitters, thus increasing the bioavailability of them. So a whole bunch of different ways that you can target these guys, okay? Now, when you look at the nervous system, you've got the central nervous system, which refers to all the things going on in the brain, and then you've got the autonomic nervous system, and that's basically responsible for the fight or flight mechanisms in the body, and also all the automatic processes in the body. And so when you look at the autonomic nervous system, you've got the sympathetic nervous system, which is responsible for the fight or flight, and that's the main neurotransmitters in that involve epinephrine and norepinephrine. Then you've got the parasympathetic nervous system, which is involved with maintaining digestion primarily, and a lot of other effects that are kind of the opposite effect of the sympathetic nervous system. So kind of that couch potato picture. So you're sitting on the couch, you're watching TV, your pupils constrict so you can focus on the TV, your digestive juices start flowing better. It also promotes urination and defecation and a number of other things. And then the somatic nervous system refers to the effects on muscle contractions, stimulation of the muscles. So what's interesting is that all these wings of the nervous system rely on acetylcholine at some point. So acetylcholine is in the synaptic ganglion for both the sympathetic and the parasympathetic nervous system. And then acetylcholine again is used in the parasympathetic nervous system at the muscarinic receptors, and that's for the end target organs for the parasympathetic nervous system, while the sympathetic nervous system uses epinephrine and norepinephrine. And then also the somatic nervous system also uses acetylcholine as well, okay? So that's just a quick little review. You guys have covered this in other courses. Now, a bunch of neurotransmitters worth talking about a little bit are the catecholamines. And so catecholamines are, as we mentioned earlier, are a type of phenolic compound. Remember when we're talking about phenolics, that have your phenolic ring has two OH groups on it that are side by side, and that gives it the catechol structure. So catecholamines mean that you've got a catechol group with an amine attached to it. And so your main neurotransmitters that fall into this category are going to be norepinephrine, epinephrine, and dopamine. And so when you stimulate the adrenergic receptors with norepinephrine and epinephrine, you get that classic fight or flight response where the pupils dilate, your bronchioles dilate, you increase the rate of the heart, increase the force of contractions, blood is redirected towards muscles. And so most of the primary effects of the epinephrine and norepinephrine is going to be to make your muscles work better, so that you get more oxygen, more blood flow. Also, you increase blood sugar. And so the benefits of that is that you have your body's primed to fight or run away, okay? Also, because things like digestion is not as important, it kind of shuts that down, as well as urine output. You increase sweating. Maybe it makes you more slippery if someone tries to grab you, and you're more focused mentally, okay? A lot of the various herbs and drugs that target these receptors are involved with things like attention deficit disorder. So if you give someone a stimulant who's got ADHD, it'll get them to focus more. Also, by blocking some of these things, you can have a positive effect on lowering blood pressure and heart rate. If you stimulate certain adrenergic receptors, you increase the bronchioles, you get them to dilate so you get more air in there. And then they have some other roles involving urinary flow, like BPH and enlarged prostates in men, and also mood disorders, okay? So in general, this is kind of a little visual of what happens when you stimulate the sympathetic nervous system. Again, focus, increase heat, increase bronchodilation, increase cardiac output, and then you block urination and digestion, okay? Now, dopamine is another catecholamine. It has a stimulating effect that can probably overlap with some of the epinephrine and norepinephrine. I wouldn't be surprised if dopamine also can modulate some of those receptors and have that effect as well. Its main effect is more in the central nervous system, where it stimulates, where it's involved with concentration in particular, and also the reward mechanism. So the classic sort of thing is when people take cocaine, it increases the amount of dopamine in the body and makes you feel euphoric like you do if you're gambling and positive things, moods involved with serotonin and dopamine. So you get that little high that you get from that makes you feel good. You feel very nice. You feel really good, alert. But it also has effects in other parts of the brain involving concentration and movement. So Parkinson's disease involves dopamine, decreased amount of dopamine. Also, dopamine stimulates gastric motility, and so blocking dopamine will have a positive effect in suppressing nausea and vomiting and diarrhea and conditions like that. And also dopamine has an effect in the pituitary gland in regulating prolactin levels and having a cascade effect on a whole bunch of different things. And so certain herbs like Vitex, which is a hormone regulator, actually modulates dopamine receptors to decrease prolactin levels. This can be used for PMS and other types of conditions, and also for regulating hormones. So the main drug choices for this is going to target things like ADHD, schizophrenia, and psychosis, because one of the things is excess dopamine can cause hallucinations. It's also involved with nausea, hormonal imbalances, drug addictions. So whether it's stimulating or suppressing it will have an effect. So this is a little visual picture. I used to teach the nervous pharmacology of the nervous system, and that's why I'm kind of borrowing some of these slides, because it's a nice little review and students liked it. I'm not teaching anymore just because they kind of revamped the course and I couldn't commit to it with all the babies in my life these days. So I gave it up, and but these are still useful for you. Less so for herbal medicine, but just general knowledge. So dopamine's involved with hallucinations, nausea and vomiting, focus, reward. A little bit of dopamine is good for your coordinating muscles, but excess will cause spastic movement of your muscles, and then also prolactin levels. We're not testing any of this stuff directly, okay? The only thing I'm going to be testing on here, Ali, is, so I won't be asking necessarily those things, but more the effects of like what herbs are interacting with what aspects of the nervous system, okay? So I'll give you an example. You'll see the questions later on, sample questions. So when it comes to the nervous system, you can increase certain neurotransmitters by breaking or by blocking enzymes that are involved with the breakdown of them. So there's an enzyme called monoamine oxidase, which is responsible for breaking down the monoamine neurotransmitters. And these include the epinephrine, norepinephrine, dopamine, serotonin, and a number of other ones. Catechol-o-Methyl transferase enzymes responsible for breaking down only the catecholamines, okay? And I'm giving you this is a little overkill for what we're going to do today, but it's useful for understanding how some of these herbs work, okay? So these are the two main enzymes involved with breaking down epinephrine, norepinephrine, and dopamine. And so monoamine oxidase enzymes, as I mentioned, serotonin, melatonin, epinephrine, norepinephrine, dopamine, also some other ones that we discussed when we're talking about ayahuasca, like dimethyltryptophan, which is found in some plants, and also tyramine, which is found in fermented foods. Catechol-o-Methyl transferase, like I said, only involves the catecholamines, dopamine, norepinephrine, and epinephrine. Okay? So that's a quick little background. When it comes to alkaloids, we're going to talk about first are the protoalkaloids. Okay? So these are phenethylamines. Okay? So these phenethylamines are not true alkaloids because the nitrogen is not actually in the ring structure. These, like some of the phenol compounds we talked about, are related to compounds like phenylalanine and tyrosine, where you basically have this benzene ring with a side chain. In this case, you've got two carbons in the amine group because they've knocked off the carboxylic acid group. Now, when it comes to tyrosine and phenylalanine, is when you remove the nitrogen from it, when you take that away, it essentially loses that strong stimulating effect that these compounds would have on the nervous system. Okay, so once the nitrogen's removed, it's not really going to have a stimulating effect. I still think when we're looking at a lot of the catechol-amines, the phenol compounds that we talked about, they can still probably have a weak modulating or inhibiting effect on probably some of these catecholamine receptors. Just they'll probably fit in the grooves, but not stimulating. So they have sort of more of a blocking effect. And that may be one of the mechanisms that some of these, the phenol compounds that we talked about, can have a positive effect on blood pressure or on mood and things like that. Okay. Somehow it's sort of modulating some of these receptors. Okay. Now, with regards to the phenethylamines, these protoalkaloids, these compounds have a stimulating effect on a number of the enzymes and receptors involved with dopamine and norepinephrine, epinephrine. Okay, so when you look at the catecholamines, our neurotransmitters, they're on the left-hand side. On the right-hand side are a bunch of compounds that we're going to talk about that are found in plants. Some of these you might use in practice. Some of these you definitely won't use in practice, and some of these are in your diet, and it's just worth understanding how it all kind of fits together, okay? So when you look at this, the compounds on the right-hand side have a similar structure to the catecholamines on the left. So it's not surprising that they will exert some effects on these systems, okay? And how do you make it? Phenylalanine, tyrosine are your amino acids, your starting points, and they're basically used to create ephedrine, tyramine, synephrine. And then the phenolic acids that we talked about earlier on, like fumaric acid, the way that they're made is they remove the nitrogen, while the ones at the bottom remove the carboxylic acid group. And that's what makes it active. So we've already talked about ephedrine, okay? Ephedrine is the main active compound in ephedra, the herb. There are different species of ephedra around the world that have been used. So there's some that are used in Western herbalism, some of them are used in Eastern herbalism. And when we go back to the first lecture, remember when we talked about the ancient Egyptians, they were using a primitive type of puffer by taking ephedra and squeezing it between two hot rocks and inhaling the vapor. And ephedra, it acts as what's called a sympathomimetic. And what that is it's a compound that mimics the sympathetic nervous system. And so it exerts a similar effect that adrenaline would, but to a much lesser degree, okay? And so when you think of all those effects we talked about when we're talking about epinephrine and norepinephrine, where you increase your heart rate, you increase blood pressure, it increases, causes the bronchioles to dilate, it redirects blood flow, it acts as a stimulant. These are all the same things that ephedrine, the drug or the herb, does, okay? And so ephedrine is historically used in Asian medicine and also Western medicine for colds and flus because it acts as a decongestant. And one of the ways that it does that is it causes vasoconstriction of certain capillaries in the sinus cavities, and by constricting them, it makes them less leaky, and by making it less leaky, you have less fluid going into the interstitial space. So when you have a nasal congestion, like I have right now, just fighting the cold, you might have some phlegm in the nose, but that bogginess, that sort of plugged up nose, like I can breathe right now, okay, like my airways are clear, but they're congested. And so what's going on there is that the interstitial fluid is increased. So the amount of fluid in between the cells has gone up, and that's what's causing that stagnation, that sinus congestion. So no matter how many times I blow my nose, I won't get rid of that fluid, that water that's between the cells, because it's not in the airways. It's just like when you twist your ankle and it swells up, or someone has congestive heart failure and there's all this edema, this swelling in their ankles. That's kind of what I have going on. It's like I've got congestive heart failure in my nose. You know, I got the swelling in my nose. And so what things like ephedra would do, also coffee would do this to some degree, not to the same amount, and also a shot of adrenaline would certainly have a significant decongestion effect. By tightening up those capillaries, it makes them less leaky. There's less fluid flowing in between the cells, so it dries up the sinuses. Okay, so that's how a lot of these cold medications work. Is some of them work as an antihistamine. So just as an aside, the antihistamine ones are the drowsy ones that make you sleepy, while the non-drowsy sinus and cold medications usually have some ephedrine in it. So it's a drug, but it's originally derived from a plant. Okay, so it will open up the bronchioles a bit, dries up the lungs a little bit, but it's used mostly for respiratory tract infections and sinuses, and also seasonal allergies, because it'll have that decongestion effect. Now, some off-label indications for ephedra, the herb, is using it for a weight loss product. And so it's been banned by the FDA and Health Canada, because when you stimulate the sympathetic nervous system, it increases fat breakdown in order to release more fuel. And so you can take ephedra, the plant, or cold and flu medication that contains ephedra in high amounts. It'll stimulate metabolism, leading to fat breakdown. And you can shed some pounds pretty quick by doing it. And that's one of the other reasons why, if you look at, you never see people who do a lot of crack cocaine or crystal meth, or who are heavy users, they never are overweight, right? Because they don't eat a lot, and their fat's being broken down. So by people wanting to lose weight, ephedra is highly effective. The problem is that because you're stimulating the sympathetic nervous system, you're going to increase the risk of having a cardiac event. Now, it's likely that in a healthy individual, taking small amounts is probably not going to cause significant harm. But most people who are morbidly obese or overweight trying to lose weight, they didn't get that way from eating fruits and vegetables. They probably got that way because they're eating a lot of junk food, which is clogging up their arteries. So when you elevate blood pressure, increase blood sugar, increase heart rate, you could cause a serious cardiac event like a heart attack or even death. So there have been deaths associated with people abusing ephedrine. So in general, I wouldn't recommend using it for weight loss. Realistically, if you have a healthy young person who's trying to like shed a couple pounds before the wedding, probably wouldn't kill them. But I'm not really condoning that. I'm just sort of saying, realistically, that group of people probably would be less likely to be harmed by doing it. But you're better off dieting, eating less sugar, doing all the things that you're supposed to do. Also, just as an aside, if you're doing weight loss in practice, make sure you look into food sensitivities, because a lot of people who are having troubles losing weight, they may be eating their eggs and their dairy, thinking it's good for them for weight loss, when in actual fact, even though it's high in protein, causes an inflammatory response, which makes it difficult to lose weight. So it's just a side note. So ephedrine, it has all these effects. It acts as a stimulant. In addition to working on ephedrine or epinephrine or norepinephrine, it does have an effect on dopamine. And so taking ephedra regularly does have a slightly addictive effect, just like smoking or cocaine would. So because it modulates all those. Now, when you take something like adrenaline, when you get a shot of adrenaline because you're almost in a car accident, or you were to take an EpiPen and give yourself a shot, both of those situations, partly because when you give an injection, you're going to get a different route of administration. But even if it's released from your body, you get that instantaneous, within seconds, it's released from the adrenal glands. You get this shot of adrenaline, all of a sudden, like boom, you can feel it. It's powerful, really, really powerful. But that shot of adrenaline, once the the danger wears off, it gets removed very, very quickly from the body. Okay, and you might have a little bit of I remember once I was almost in a car accident. I wasn't, and it wore off after minutes. But it was pretty intense when you get that shot of adrenaline. Now, ephedrine doesn't give you that same major intense spike, and it also lasts longer. And one of the reasons for that is when you look at the structure, they're very, very similar, norepinephrine and ephedrine. They're very, very similar in structure, but one of the main differences is they don't have, ephedrine is not a catechol-amine. It doesn't have those two OH groups. So it exerts its effect in the body through different mechanisms. It may modulate the epinephrine, norepinephrine receptors a little bit, but it also appears to inhibit their breakdown in some other ways. So what's interesting about it is that, and it may actually increase the release of these through other mechanisms. So its mechanism is it's not identical to norepinephrine the way it works. But one thing about it is because it is a monoamine oxidase, so it's inhibited by that enzyme, it's broken down by it, but it's not a catechol-amine. So what that means is it's not going to be inactivated by the catechol-o-methyl transferase enzyme. So it will last hours in the body and give less of a peak. So it's better suited for sinus colds because it'll last you for a good part of the day and not cause as much as serious side effects as taking adrenaline. So if you have a little bit of nasal congestion, you don't want to just give yourself a shot of adrenaline because it would just be too powerful and it wouldn't last long. So you get a much broader curve for how long it lasts in the body. Okay, so that's ephedrine. Now, synephrine is a compound very similar to ephedrine. Okay, but the difference here is it's coming from bitter orange, and so bitter orange is historically used. It grows in Spain, other parts of the world. You make marmalade out of it, and even marmalade, when you eat it, because they use the rind, it does contain small amounts of synephrine in it. Not a huge amount, but a small amount. Now, bitter orange peel is used in Chinese medicine for a whole bunch of things, including digestion as a decongestant. It can decrease spasmings in the digestive tract. Also, adrenaline will do that as well. And sometimes used for weight loss sort of pictures because they recognize that. It does, I think, it can be abused and cause elevation of blood pressure. There are, misuse of it can cause potentially heart attacks, but it does seem to be remarkably a little bit safer, at least what I've read in a herbalgram, which is published by American Botanical Council. It might be a little bit safer than ephedrine is. Structurally pretty similar. The take home here is both bitter orange and the herb ephedra contain sympathomimetics that can be used for respiratory issues, can also be abused for weight loss. Okay. Now, another compound called tyramine is not necessarily a phytochemical. It's actually found, it'll be found in your diet, in vegetables, but it's also found in lots of fermented and cured foods, okay? And so naturally tyrosine, the amino acid, can be metabolized and fermented to make tyramine. And so you'll find it in some of my favorite things like wine, beer, cheeses, cured meats, avocados, chocolate, also overripe fruit that are being fermented. And so this compound is actually a pretty strong sympathomimetic. It actually will have a similar effect on your body that ephedrine would, or that, what else would have this effect? Even adrenaline to some degree. And so when it gets into your bloodstream, it basically binds through adrenergic receptors and will elevate blood pressure and cause an increase in heart rate, and all those things that we talked about earlier, that you'll see with some of the other sympathomimetics, and it has the potential to cause death by causing a hypertensive crisis, by elevating your blood pressure, getting your heart to function or to beat too quickly and too strong a force of contractions, and cause headaches, all these other things. The reason why we don't have a problem with tyramine in our diet is because our gut is lined with monoamine oxidase inhibitors. And so otherwise, every time you had a piece of chocolate or a whole bunch of chocolate and had some wine and cheese and all these things and ate some cold cuts, you'd be having basically elevated blood pressure and potentially dying. Okay, so these monoamine oxidase enzymes in our gut break down tyramine, as well as some other neurologically active compounds as well, to prevent them from being absorbed and having this effect on our nervous system. So tyramine does not pose a real risk to us in our diet, except for some susceptible individuals, or if you're taking drugs that inhibit monoamine oxidase enzyme, okay? And there are some herbs that inhibit monoamine oxidase enzymes, and certainly there are an old class of antidepressants that are sometimes used for certain types of conditions that can have that effect as well. And we'll come back to those monoamine oxidase inhibitors later on. So some other kind of fun and interesting plants from an ethnobotany standpoint are the certain hallucinogens. So I think most people have heard of mescaline or peyote before. It's certainly portrayed in a lot of Hollywood films. If you've ever read any Carlos Castaneda books, which are kind of fun books, they're kind of these new age spiritual books written in, I think, the 60s or 70s about a guy, an anthropologist who went and studied with a shaman in somewhere in, I think it's New Mexico, and talked about his experiences doing peyote. Whether it's fictional or not is up to debate, but they're kind of interesting. So mescaline is the active compound in peyote. It's also found in San Pedro's cactus, which is a really nice ornamental cactus that you can buy in North America. I remember I was working at Parkdale Community Health Center, and I was in the doctor's office that I shared there, had a beautiful San Pedro cactus in it. And I kind of was chuckling to myself, thinking he has no idea that it's just loaded full of mescaline. And if you wanted to, you could basically chop it down and consume it and have the same effect as peyote. And so you can find this in North America. It's totally legal to possess it. It's just illegal to take it as a hallucinogen. So in South America, San Pedro's cactus is up in the Andes, and this is used by some shamans in Peru and other South American countries. And it would be similar. I've never done it. I have no idea what it's like, but I guess phytochemically and pharmacologically, it should be similar to the effects of peyote. And so mescaline, it interacts with both dopamine and certain serotonin receptors to have a very powerful hallucinogenic effect. And it seems to be longer lived than other things like ayahuasca or magic mushrooms. I remember hearing of one report of some guy who bought it and took mescaline recreationally in some city. It might have been in Toronto. And he got arrested by the cops because he ended up doing it on a Sunday or whenever it was, and he ended up being naked at some schoolyard playing in the sandbox the next morning and got arrested. So, probably better reserved for taking it when you're in the Andes or in the deserts of Peru with people who know what they're doing. I wouldn't mess around. I think these are pretty powerful things. I wouldn't mess around with them personally unless you're with the culture and the shamans know what they're doing. But these are used for thousands of years in these cultures. And if you look on the right-hand side, this is, I was in a Peruvian market down in South America, and you can see they have it on sale. It's all cut up, dried, ready for someone to buy it and take it. And if it's just, they're selling it at the market, someone must be doing it. So, oops. rats. I really find it frustrating when my slides jump. Let me just see. So the artwork on the left-hand side, the tribes in Mexico that are known to be the peyote users and the shamans in that culture are part of the Hueco tribes. And so this is artwork that they make, and they use yarn to make it. And you see it's all outlined, the colors are intense. That's sort of a classic visual representation of sort of what the visions are like with people who are doing peyote. And I would say that because it's interacting with similar receptors that you see with ayahuasca, magic mushrooms, LSD, that's sort of a common sort of depiction of the visions in any of those hallucinogens. They're all in the same family, so they're going to be different, but they're all going to be cousins of one another. And so in the center is the picture of the peyote cactus and the various animal spirits that are, these are deer on the left-hand side that are, they're talking about a trip or a voyage, and you see they're on a boat, which depicts the voyage. So it's kind of beautiful. I bought this one on eBay got it from Mexico. It's kind of a neat painting. My wife thinks it's weird and won't let me hang it up in the house. So someone's asking, is it in kombucha? I don't think so. If it was, there'd be kombucha would be way more fun or interesting than it is. So kombucha may have tyramine. I don't know if you're talking about tyramine being in kombucha or if you're talking about mescaline. Maybe you're talking about the tyramine. Probably tyramine's in kombucha. I don't think mescaline's kombucha though. So the next group of alkaloids, so those are some protoalkaloids that we talked about. Interesting, not really, most of them aren't that relevant to herbal medicine with the exception of the ephedrine, at least the herbal medicine you're going to practice. But when you look at some of these hallucinogens that we talked about, they've been a part of these traditions for 5,000 years or more. So they are relevant. They're just not going to be that relevant to your private practice. I just think from an ethnobotany standpoint, from a cultural standpoint, it's really intriguing, the use of these things. Now, purines, these are widely used. And so I would say they're kind of a dietary non-essential nutrient. There's a lot of some health effects related to purine alkaloids. Most people in, I would say, the nutrition realm don't refer to them as purine alkaloids. They're called methylxanthines, okay? And structurally, these methylxanthines are related to compounds like purine, which is found in like the building blocks for DNA have a similar structure of these, okay? They're also similar to another compound called adenosine, which is something that when you go to the gym and you work out and you feel kind of that relaxed state and even sleepy after a really intense workout, that's related to the liberation of adenosine in the body, and that acts as a calming effect, okay? Now, caffeine is the classic purine alkaloid, and there are other compounds related to it, like theobromine, which is found in chocolate and tea, and there's some other ones. But all these compounds have some stimulatory effect in the body, okay? So they act as a stimulant. Anyone who drinks coffee will know that. Some of them have a stronger diuretic effect. Certainly I find tea is a stronger diuretic than coffee is, and that may be related to the theobromine, and it does have caffeine. Some of them act as bronchodilators. And the way that these guys work is unlike ephedrine that kind of directly targets some of the receptors involved with releasing more epinephrine, norepinephrine, and just works by different mechanisms. One of the ways that these guys work is indirectly it stimulates the sympathetic nervous system. There's a nice picture of coffee growing in Central America, I think. Yeah, Central America. It was Costa Rica. So the way that it works is you've got an adrenergic receptor that epinephrine will bind to on your cell. And then what it causes this little reaction. You may have taken this in biochemistry. I assume you did. You may have forgotten about it. But when epinephrine binds to it, this G-coupled protein releases the G protein that then binds to a compound called adenyl cyclase, which takes ATP and converts it to cyclic AMP. And cyclic AMP is an intracellular messenger, and that's what's responsible for causing all the cascade of events within the muscle cell or whatever cell it is that causes smooth muscles to relax or makes the heart muscles beat stronger. It's responsible for causing the breakdown of starch into making more sugar. It's also responsible for breaking down fats. And so the sympathetic effects that occur are related to the release of the cyclic AMP. Now, cyclic AMP gets broken down by an enzyme called phosphodiesterase, okay? And by doing that, once it's broken down, it's inactivated so that you no longer have the sympathetic effects taking place. So when you get a little shot of adrenaline, or always in your body, there's epinephrine, norepinephrine, and dopamine are being released all the time, but they're kept in check by various enzymes and other things. So the way that caffeine works, though, is it doesn't directly bind to this adrenergic receptor, but rather it binds to the phosphodiesterase enzyme, and that inhibits the breakdown of cyclic AMP, and that allows for that intracellular messenger to remain elevated in the cells for a longer period of time. And so the epinephrine that's naturally floating around binds to the adrenergic receptor, causes this cascade, and the caffeine just potentiates it, just allows it to persist and go on longer and longer, okay? So if you look at the structure of ATP, this compound here is very similar to the methylxanthine, right? So it basically blocks the phosphodiesterase enzyme because it kind of has a similar structure to it. And that's usually how a lot of the herbs, a lot of the pharmacological effects of drugs and herbs is related to similar structures that can fit inside the enzymes, okay? So methylxanthines basically inhibit that phosphodiesterase enzyme. Another thing that they do is maybe I didn't include it. Another way that caffeine works is it may block the adenosine receptors in the brain. And adenosine normally has a calming effect. And when you block the adenosine receptors, it also stimulates the release of epinephrine and norepinephrine, or one of them. I don't know if it does both. And that's another way that you're not only blocking the breakdown of this cyclic AMP, but you're also indirectly stimulating the release of it as well, okay? Adenosine receptors. So when you go to the gym, I find if I have a whole bunch of coffee and I go to the gym, I feel pretty good afterwards, and I don't get sleepy, and I don't get jittery, because if I drink a lot of coffee without going to the gym, I often will get jittery because I've overstimulated myself. But the adenosine from the gym kind of helps to balance the caffeine, and the caffeine helps to prevent the fatigue post-workout. So they kind of go hand in hand pretty well. Jessica was saying, I was watching the Goop Lab, and they were talking about clinical trials using psychedelics in conjunction with psychotherapy, specifically with post-traumatic stress disorder. I don't know a lot about it. First of all, I've heard nothing. I've heard a lot of negative things about Goop Lab from on Reddit and stuff like that. But so I can't say everything they talk about has good science to back it up. But certainly that one, I do know that with things like ayahuasca, even ecstasy, the drug, they're using them for healing processes. And I'm not surprised, because all these things basically help with neuroplasticity, and they They help to rewire your brain, and I think you have to be very careful with them. There's people have bad negative experiences with them, just like any potential therapy. There's potential side effects. I think it could induce a psychosis. It could lead to death. I think the other problem, just as an aside, when you're looking with shamans maybe evolved on a spiritual level, just like you could have someone like a spiritual guru in India, maybe really evolved in a spiritual realm and be very wise, but then be totally messed up in like a sexual realm where he ends up sexually abusing their followers or their patients or the people who come to get help. So I've heard a number of reports of people being sexually abused by shamans, or also, there's a long history of this going on in India with, Westerners going over and seeking wisdom from gurus, and the gurus end up getting in trouble because they, start sleeping with their students and stuff like that. So you got to watch that as well. But anyways, with regards to the research, there's a whole bunch of studies showing things like ayahuasca. There's another drug called ibogaine, which comes from West Africa, and there's a really neat documentary on YouTube talking about ibogaine for heroin addictions, and people who have been struggling with heroin or other opiate addictions for years, and their families can't help them, and they get them to do ibogaine, and they do one treatment, and they're totally cured of it. These are not to be taken lightly, these are not really recreational things, I think, for people. I think some people might try to use them that way, but you got to be careful. But there is a lot of research if you look at these things for post-traumatic stress, for depression. Studies going on with magic mushrooms with people with terminal cancer, being able to process and accept their experiences better. So, I think hallucinogens have a spot in healthcare. Maybe not for everyone. I think meditation's a lower risk thing, but it's got a place, in my opinion. Just legal reasons, we gotta be careful with that, though. Some countries these things are legal, and other countries are not. So don't get yourself in trouble. So the parasympathetic nervous system, if you remember, this is the kind of the couch potato response. So this is when you're relaxed, you're sitting down, you're watching TV, you're eating a bag of chips, your eyes are basically constricted so you can focus on the details of the television, or when you're reading a book, you're nice and relaxed, so you don't need to have your bronchioles dilated, so they tend to constrict because you don't need as much air. You need your digestive function working better, so stomach acid, digestive enzymes, salivation, going to the washroom as well. Maybe you're watching some romantic comedy and it's making you cry as well. So basically, when it comes to the parasympathetic nervous system, it's stimulating almost any of your secretions or excretions are stimulated with it, okay? So lots of fluids going on here. Urination, defecation, saliva, crying, sweating, everything, okay? So acetylcholine is the main neurotransmitter with this. Now the name muscarinic receptors comes from Amanita muscaria, which is the fly agaric mushroom. This is the classic fairy tale mushroom that has the red cap with the white dots. That's what tends to grow in Asia and the west coast of Canada. Around here, we don't get the red one. We get a different variety. It's the same genus, same species, but it's got a yellow cap with white spots. This is not the same as a magic mushroom that contains psilocybin that binds to serotonin receptors, okay? So even though the fly agaric mushroom produces hallucinations, it does it through a different mechanism. So the big thing that happens is that if you consume the fly agaric mushroom, what ends up happening is it stimulates the parasympathetic nervous system, and that causes nausea, vomiting, diarrhea initially. Now, it does contain a hallucinogen in it that works more on the GABA system, which produces more of like a lucid dream-like state. And GABA is also stimulated by things like benzodiazepines and certain herbs like kava, passion flower, valerian also stimulate that system. So shamans in Siberia use fly agaric mushrooms as hallucinogens. Just as an interesting aside, if you drink it, if you eat the mushroom, you get all the symptoms that you don't want, the nausea, vomiting, and diarrhea, due to the stimulation of the parasympathetic nervous system. But when you urinate, you basically excrete the hallucinogen that stimulates the GABA receptors, but it breaks down the muscarine molecule that has the parasympathetic effects, gets broken down in the liver or wherever it is. So if you drink the urine of someone who's eaten the mushroom, you get the hallucinogenic effects without the nausea, vomiting, and diarrhea. So, although it doesn't really sound that appetizing. So I would stay clear of this mushroom altogether. You can die. It's probably magic mushrooms are probably the safest hallucinogen. I think like it's one of the safest hallucinogens. I think it is probably the safest hallucinogen. I don't know if there's any deaths reported with it. Peyote and mescaline-containing things is certainly a little bit higher risk because of the involvement with the sympathetic nervous system. There have been a couple of reports associated with people doing ayahuasca. They may have had, it could have been the wrong plant mixed in there along with it, or it could be that they had some predisposed heart condition and then were under stress when they're taking it, and that could be an issue. Magic mushrooms seem pretty safe though, but not these ones, okay? So, Muscarine, which is the compound in the fly agaric mushroom, and they call it, sorry, just as an aside, they call it fly agaric because it used to be used as fly poison. So Muscarine is the first compound they found that binds to muscarinic receptors that are involved with the parasympathetic nervous system. Okay, that's where the whole story comes from. Okay. Another way you can stimulate the parasympathetic nervous system, in addition to giving something that directly binds to muscarinic receptors, is to take something that inhibits the breakdown of acetylcholine. So there's an enzyme called acetylcholinesterase, or sometimes just cholinesterase. That enzyme breaks down acetylcholine, okay? And that inactivates it. So that's the quick little background there. You don't need to know anything about the Amanita, fly agaric mushroom. But you do have to know just the general class for these compounds come up here. Imidazole alkaloids, they get their name because they have an imidazole ring. And that's basically a 5-membered ring with 2 nitrogens on it, okay? I probably won't ask you any kind of question on like the actual ring structure because I think that's just too difficult. But I could ask, imidazole alkaloids are known to have a stimulating effect on the parasympathetic nervous system. That I might ask. Or I might say pilocarpine is a herb that contains, Jumborandi contains pilocarpine, and pilocarpine is an imidazole that is known to have the following effects, okay? So pilocarpine has been used in the pharmaceutical realm, but it's not very safe. Anytime you take something that stimulates the parasympathetic nervous system, you can die from it. And the reason why is that if you overdose, you basically die of dehydration because you just lose all your bodily fluids and you go into like hypovolemic shock, okay? Basically your blood pressure drops and you die. So when you overstimulate the parasympathetic nervous system, there's a good acronym called SLUDGE: salivation, lacrimation, urination, defecation, GI upset, emesis. Okay, and that's what can occur. So a little bit of the herb Jumborandi or a little bit of the drug pilocarpine might just stimulate digestive function a bit, but you can easily overdose and die. Here's a little mnemonic if you like mnemonics. Pilocarpine. So here's a carp or a fish. Here's the muscarinic, the fly agaric mushroom, Amanita muscaria on the left-hand side. So both these, the mushroom and the carp, are basically They're crying, they're vomiting, they're urinating, they're defecating. It's messy, okay? Really, really messy. So if you take too much of this, it can cause a lot of problems. So overstimulation of the parasympathetic nervous system causes cramping, a lot of pain associated with it as well, okay? So you probably will never learn that. We're learning this more in the context of phytochemical classification, and when you're looking at imidazole alkaloids, these are the main ones that are interacting with the muscarinic receptors, okay? So they bind directly to the muscarinic receptors. Now there's another group of compounds called pyrrolidine alkaloids, a bit of a mouthful. There's a compound called physostigmine, which was used in the pharmaceutical realm. What this basically does is it doesn't bind directly to the muscarinic receptors, but rather it blocks the cholinesterase enzyme, okay? So when you block the breakdown, the enzyme involved with the breakdown of acetylcholine, then you have more acetylcholine around to bind to the muscarinic receptors. So both physostigmine and basically the pilocarpine, both those compounds will all stimulate the parasympathetic nervous system, but through a different mechanism, okay? The end effect's the same. Also, you may have heard years ago there was a terrorist attack in a subway in Japan where somebody released basically nerve gas into the subway and killed a bunch of people. So nerve gas is also called sarin gas, is related to a number of organophosphate insecticides, and these inhibit this cholinesterase enzyme, and so it's a real mess. When you get poisoned with that, nausea, vomiting, diarrhea, you die. So it's pretty awful, okay? And that's related to this effects. So these are both parasympathomimetics, okay? So parasympathomimetic mimics the parasympathetic nervous system. Okay, so here's a little mnemonic: physostigmine, the caliber bean, all the gas and bloating and nausea, vomiting, diarrhea, and also nerve gas poisoning does the same thing. We'll come back to these guys in a second. Now there's two other structures, pyridine and pyrrolidine alkaloids. These are both found in nicotine. So nicotine has both of these two structures in it. One's a tertiary amine, which means it has 3 carbons attached to it. The other one has this aromatic ring structure with the nitrogen in it. What's interesting about it is nicotine stimulates both the sympathetic and the parasympathetic nervous system, and also there are spots in the central nervous system where it acts on as well and releases dopamine. And so there are nicotinic receptors in all wings of the nervous system, both the autonomic and central nervous system. Right? These are nicotinic receptors at the synaptic ganglion here, here, and here. So at the sympathetic, parasympathetic, and somatic nervous system. And so this is kind of interesting because when people smoke, they're like, oh, I smoke because, it helps relax me. I smoke because it helps me focus. These relaxation and stimulation are two opposing actions, but tobacco does everything. It kind of helps. It can stimulate and relax. If you smoke too much, it's not good. People that are smoking or chewing tobacco, they're always spitting, right? And that's because of the stimulation of the parasympathetic nervous system. It also increases your heart rate. That's related to the sympathetic nervous system. If you smoke too much, it can make your muscles ache a bit. That's related to the nicotinic receptors on the somatic nervous system on your muscles. So smoking, in addition to the fact that it causes addiction through dopamine release, it has this grounding, normalizing effect to some degree on all aspects of the nervous system. And that's one of the reasons why I think it's so hard to give up. In some cultures, like in First Nations culture, they see it as being like a sacred plant. And, I used to smoke, and I know I enjoyed smoking. I didn't smoke a lot, but I still enjoyed it because it just made you feel kind of grounded, It's unfortunate it causes heart disease, cancer, and just such an awful poison. but it does have a very grounding effect on people if they do small amounts. But then it makes you addicted to it, and if you smoke too much, then it agitates you. And then if you are trying to quit, then you feel agitated. So it's kind of a bit of a trick. You feel grounded, but it also you get addicted and dependent on it, which is not cool. So nicotine, again, nicotinic receptors, two different, there might be a question where I say nicotine contains which of the following alkaloids? And I might put both these two names in there. I might say that it binds to which receptors in the body. I might say it stimulates which part of the nervous system. Now, tropane alkaloids are the next group we're going to talk about. These are very interesting compounds as well. There's a lot of neat botany associated with this, okay? A tropane alkaloid, you have this bridge structure. You have a tertiary amine, which means there's 3 carbons attached to it. The 2 main groups of plants that you see associated with tropane alkaloids is the coca plant, where cocaine comes from. Cocaine acts as a tropane alkaloid. And also members of the Solanaceae family. This is the tomato family or the tobacco family. And you have a number of very interesting plants like deadly nightshade and jimsonweed that are in this family. Okay, deadly nightshade was once used in witchcraft, in Western herbalism. It's a very potent drug. Jimsonweed was used by shamans in Central and South America, not as routinely as things like the magic mushrooms and ayahuasca and peyote and things like that. It's very dangerous. You don't mess around with these guys. Okay, so they have both exert an effect on the nervous system, like all the alkaloids do. Cocaine and atropine have very unrelated effects on the nervous system, except they both have slight analgesic effect. They can both act as a bit of a nerve block, okay? And that's one of the reasons why when people do cocaine, they're always sort of fidgeting with their nose, is because it has that numbing effect in their nose. You can also, cocaine is used as a building block to make other important analgesics, okay? So one of the things to take home though with tropane alkaloids is when you hear that, you think, ooh, not safe, because they're found in deadly nightshade, okay? Anything that starts with deadly is not safe, okay? So deadly nightshade contains tropane alkaloids, and you can overdose and die from taking too much of this. They are available commercially as drugs. So atropine and scopolamine are used by medical doctors. They're used for, and some compounds related to this. The way that they work, these particular ones, is atropine works as a anticholinergic, okay? And what that means is it basically blocks the sympathetic nervous system. And so it blocks the muscarinic receptors and suppresses the parasympathetic nervous system, okay? What I would do is add oops. Are you sure? Yeah, I want it. No, I want it. They want me to update again. I'm always terrified to update. Anticolon. I got a new, brand new laptop a month or 2 ago, and they changed the operating system. So now all these programs like Photoshop and Microsoft Office and a whole bunch of other things, none of them will work on it because they don't support the 64-bit or 32-bit or whatever it was. And now, these softwares want me to pay an annual fee, and I was like, well, there's nothing wrong with what I had. So I hate updating. It messes stuff up on me. So anticholinergics, that precise mechanism, it's the opposite of sympathomimetic. Or sorry, it's the opposite of, not sympathomimetic, parasympathomimetic. It has the opposite effect. So it has a lot of effects that are similar to activating the sympathetic nervous system, because when you suppress the parasympathetic nervous system, you kind of allow the sympathetic nervous system to take over. So here's a little mnemonic for anticholinergics. Here's your deadly nightshade berry. It's in the middle of the desert. It's got sunglasses on. It's super hot. It's red. Everything's dry. So when you suppress the parasympathetic nervous system, all those fluids, the lacrimation, the defecation, the sweating, all that basically goes away. So you dry up. Your pupils dilate because when you stimulate the parasympathetic nervous system, your pupils constrict so you can focus and read books. When you stimulate the parasympathetic the sympathetic nervous system, your pupils dilate. So if you suppress the parasympathetic, you get a sympathetic dominance, and that's why a lot of these things mimic that. One of the mnemonics for it also is hot as a hare, because you're not sweating, so you tend to overheat, you turn red. Blind as a bat, because your pupils are dilated, you can't see very well because too much light's coming in. Dry as a bone, like I said, sweating. Zero red as a beet because you're not sweating as well. Mad as a wet hen. One of the other effects unrelated to the blocking of the parasympathetic nervous system, I think, is that they cause weird hallucinations, apparently. I wouldn't know, but from personal experience. But these anticholinergics, the deadly nightshade were used by witches, causes some crazy hallucinations, and then the shamans would smoke devil's trumpet or other members of Datura. Datura was also found in India. They would drug people. I remember I heard once that they would drug people on subways and stuff with them, or trains. So you don't want to mess around with them. But anyways, quick little summary. Acetylcholine stimulates the parasympathetic nervous system because it binds to muscarinic receptors. Muscarine and pilocarpine also bind to the muscarinic receptors. Okay? Atropine blocks those receptors and prevents the binding of acetylcholine or muscarine or pilocarpine. Okay? Phytochemicals, the way it works, it inhibits the breakdown of acetylcholine, and that allows more of the acetylcholine to bind to the muscarinic receptors. Atropine, just so you know, it's the antidote for nerve gas poisoning. So if someone overdosed on pilocarpine, or they ate a fly agaric mushroom and were vomiting and had a lot of cramping pains and all these issues, or they're exposed to nerve gas or phytochemicals, the antidote would be to take atropine injections. And so the military personnel carry around little atropine pills right on them, so that if they're exposed to nerve gas, that's the antidote for it. Okay. Why does atropine slow down the heart rate? Did I say it slow down the heart rate? Because I'm pretty sure it increases the heart rate. To the best of my knowledge, it actually increases heart rate. What did I say? It slows it down somewhere? Now, one other thing. Maybe it's a dose-dependent thing. I would have to, because it kind of does some weird things. Like there are some conflicting things that like for example, anticholinergics will do when you stimulate the sympathetic nervous system. You also sweat. You can sweat when you're stressed out, because you're trying to get slippery. You want to escape from a bear. So some of the symptoms are not identical to stimulating the sympathetic nervous system. With regard to the heart rate, I don't know. I'd have to look at that. It does cause dilation of the bronchioles, so I'm pretty sure it increases heart rate. I'd have to go and look at that. So, but I don't want to say for certain, because also it could be a dose-dependent thing. And low dose, it may do one thing, and a higher dose it might do something else. So I'm not going to even try to explain that, because I'm not 100% certain. Okay, I might look it on the break though. So cocaine, unlike deadly nightshade, it is not a parasympathomimetic, but it acts as more of like a sympathomimetic, and it does increase norepinephrine but more importantly, it's the fact that it has a greater effect on dopamine than you'd see on like ephedrine. And that's why you get a bit of a high from it. You feel good, but it is a stimulant. Now, it affects norepinephrine, dopamine, and also serotonin to a much lesser degree by primarily blocking one of the transporters of norepinephrine and dopamine in the body. Okay. Here's a whole bunch of coca leaf down in Peru, just for sale in the local market. What's interesting about coca leaf is it's widely consumed, chewed on, or taken as a tea in South America. It doesn't have the same damaging effects that cocaine and crack does. Like coca leaf, I would say it's a herb. It's very similar to people drinking coffee or tea. When I was down in South America, I was chewing it or having it as tea. It's just a very nice, gentle stimulant. Nothing, it's very benign. Suppresses appetite a bit. It's great for altitude sickness. So if you're going to be climbing mountains in the Andes or hiking, you probably want to chew on some coca leaf. It would be indicated. It would be health promoting. In addition, in these cultures, it's kind of revered, almost like a sacred medicine. And everybody's chewing it. Little people, big people, older adults, and just like how people of all ages, well, maybe not, children don't always drink a lot of tea or coffee here, but it's widely used as a stimulant, and it suppresses appetite a bit, helps reduce fatigue. Like it's just the same way we use coffee. The difference between chewing on a coca leaf versus doing cocaine is one is the route of administration. One, when you chew on coca leaf, you absorb it in small amounts through your digestive tract. So you just kind of like what we showed you with the difference between taking a shot of adrenaline versus taking ephedrine is the spike and how long it lasts for. So when you chew on a coca leaf, there's a more gradual slope to it. So the intensity is not as high, and the period of time that it lasts it's a longer duration. When you snort cocaine, it hits the brain much faster. You get a much higher spike. You get a bigger high from it, and it's a shorter duration. So by doing that, you also release more dopamine, which makes you feel better, but then you crash quicker too, which doesn't make you feel good, and then you want more, and then you become kind of dependent on it. And the difference when you do something like cocaine or crack, so I would say there are people who have used cocaine recreationally whose lives weren't destroyed by it, but a lot of people's lives were destroyed by it. There's no doubt about it, but people can kind of bounce back from it. With crack is one of these things that's just so destructive. And once you kind of get into doing crack cocaine, chances are you're going to be hooked on it for life. And I've seen that when I worked at Parkdale, where most people who were doing crack were addicted to it, and they had a history of sexual abuse, so they were self-medicating. But even one guy I talked to, he said, yeah, he used to like to party, and he came from a rich family, and in the 80s, he would do cocaine at parties and enjoyed it. And one day, he just thought, he'll try crack, and someone offered to him, and he said it totally destroyed his life, and he's still, 20 years later, is still, battling a crack addiction. And this is a really smart guy who came from a good family who just kind of got into, made a stupid decision. And the difference between crack and cocaine is one hydrogen molecule different. And one of the things the way you make cocaine is you add basically baking soda, or the way you make crack is you add baking soda to cocaine. And by doing that, it makes the cocaine molecule more heat stable so you can smoke it. And it also, by removing that hydrogen molecule, it removes the charge on the nitrogen, which now allows it to diffuse through cell membranes and can get into your brain at a much, you need less of it to get directly into the brain. So between the fact that it's heat stable so you can smoke it and it goes directly into your brain, it causes such a huge release of dopamine that apparently the high is better than anything you could ever want. And that's kind of scary, because once you feel that good, your normal day-to-day things that usually make you feel good, like a cup of coffee or sex or whatever it is just going to seem pretty boring. So that's why it's you don't want to mess with these neurotransmitters too much. However, I have chewed coca leaf like thousands of people in South America, and it's pleasant. It's just very gentle. I wouldn't go near crack cocaine. I think it's just that would just be and cocaine. I don't want. I would not want my children doing cocaine or crack. I think that would just be too risky a thing to get into. So. That's a little pre-Columbian artifact where they used to use put seashells, which is a source of baking soda or calcium carbonate, kind of like baking soda, neutralizing that would increase the absorption a little bit when they chewed on the coca leaf. So the way that cocaine works is it blocks these norepinephrine reuptake transporters that bring the cocaine, bring the dopamine and the norepinephrine back inside the cell so they can be stored. So when you block this, you basically allow more of the dopamine and norepinephrine to remain floating around where it can interact with these various receptors that stimulate them, okay? Can we please have a break? Yep, we're going to have one right now. What time is it? Yeah, 10:52. Right now. I'm just going to enter Adam's effect. Why does scopolamine have a hypnotizing effect? Both scopolamine and atropine in higher amounts has other effects on the central nervous system, and I have no idea what the mechanism is. So I don't know what the hallucinogenic effects in these plants, how it's affected, what receptors they're binding to. I have no idea, but they definitely do. So we'll come back at 11 o'clock, okay? See you shortly. Okay, we back. Get rid of, I don't like when my personal stuff starts to spill into my lecture there. There we go. So, oops, get out of here. We have anything that private in my life, but anyways. With regards to atropine, somebody was asking, is it Jessica? Oh, Jessica was asking, why does atropine slow the heart rate? And I was thinking to myself, I don't think it slows the heart rate. I think it speeds it up. But I'm always a little bit careful about being, you know, I mean, I'm pretty sure it didn't, but you never quite know. There's just lots of things I don't know. So I double checked, and it does not slow the heart rate. It's used for a slow heart rate called bradycardia. Okay, so as I suspected, but I had to double check because I didn't know where she was getting. She seemed so confident when she said it. When it inhibits the parasympathetic nervous system, which normally slows the heart rate down, it naturally increases heart rate. So they use it for people with a slow heart rate. So if your heart rate's like 20 beats per minute, they would use it for that. Okay, in case you're wondering. So we're getting close, almost done here. And then if I have a little time at the end, I'll go and go through some of the review questions. And if you guys have questions, any questions you can ask me. Some of you guys might get kicked out of the classroom. I don't know who's there. Oops. Pyridine. So Pyridine alkaloids, they basically have a six-membered non-aromatic ring structure. You know, I don't know how important that really is to memorize. So Pyridine, there's let me go back here. The Purine, Pyridine. So this Pyridine has six-membered ring with a nitrogen. This one's the aromatic ring, okay? And this is what you find in nicotine. So they are similar, but those extra little double bonds that are in the Pyridine alkaloids does have some significant changes. So here we go. Similar, but you're missing those three double bonds, so it's no longer aromatic. Now, Pyridine alkaloids, there's a number of mixed effects on the nervous system. Pyrine is the pungent, spicy compound in black pepper that makes it, next to salt, probably the world's most used spice. I mean, salt's not really a spice. I mean, it kind of is, but it's not. But as far as plant-based spices go, black pepper is the most abundant. And Pyrine would be the main compound responsible for that spiciness, okay? Because that pungent means kind of hot, like ginger is pungent as well. You know, anything cayenne is pungent. Anything that gives it that like feeling of heat. And so black pepper is used as a carminative, but you may have heard about how curcumin is better absorbed when you mix black pepper with it. That's certainly the case in at least some studies show that in animals. I think in humans, you know, originally I thought it was humans, but it wasn't. But then I didn't think it was, and now I'm back to thinking it is again. So Pyridine may be the compound that increases the bioavailability of certain polyphenols in our diet, including curcumin, okay? Beyond that, I don't really have a whole lot to say about it. Lobeline is an interesting compound. This is a Pyridine alkaloid as well. And what's interesting about this is it historically was used for a couple of different things. One, it was called pukeweed or Indian tobacco. And it was used primarily as an expectorant to help people with respiratory tract infections. And so if you take only small amounts of Indian tobacco or lobelia, you might feel a little nauseous or not, okay? But what it does is increases mucus production, so you get more thins the mucus in the lungs by producing more, increasing the secretions, so you don't get like thick, heavy, sticky mucus. It makes it more watery, and by doing that, you're able to cough it up. Now, if you take more of it, it'll actually cause vomiting. And presumably the way that it works as an expectorant for respiratory tract infections is small amounts or large amounts. When you stimulate a part of your brain that causes vomiting, your body knows that when you're vomiting, you're going to be spilling out all this acid into your esophagus. And so in order to try to protect that, you increase more saliva and you increase more mucus to kind of help coat the mucous membranes. However, when you, and I'm sure everyone who's vomited, everyone has vomited at some point in their life, and you always know, like, when it's coming, you start salivating more, and you're like, oh God, here it comes, and you know you got a few minutes or maybe a few seconds or however long it may be before it's coming. But that salivation is such a prodrome of vomiting. So the thing is that the increased mucus and increased salivation is not limited only to your gastrointestinal tract. It also causes the same sort of effect in your lungs. And that's what you can exploit if you go with a lower dose of the herbs and you just get a little bit of this increased mucus secretion. It'll help you cough up phlegm. So that's how this expectorant action works with Indian tobacco. So historically, we used it as an expectorant in herbal medicine. We still do. So you can use it in people with bronchitis or pneumonias, really serious lung issues where they're having troubles coughing up phlegm, okay? But it's also used as an emetic. An emetic basically is something that causes vomiting, okay? Now, another indication for it is it was used historically for smoking cessation, hence the Indian tobacco, or you could smoke it. Now, what's interesting about it is that lobeline seems to have a bit of modulating effect on nicotinic receptors. And that doesn't totally surprise me, considering the fact that pyridine alkaloid is similar to the compound, to the alkaloids, the pyridine alkaloids in the tobacco. So it modulates it, but because it's not quite a good fit for those receptors, it both has a bit of a blocking and a slight stimulating effect on it. So you're not going to feel as good using Indian tobacco to replace tobacco. But one of the things that it does is it modulates it, so it makes the tobacco, the nicotine, less enjoyable. So usually when you start, if you're trying to quit smoking, what you do is a few weeks before you want to quit, you start taking the Indian tobacco, the lobelia, and you get less of a enjoyable experience from taking the cigarettes or smoking them. The other thing that it does is it inhibits the reuptake of dopamine and serotonin, but while at the same time reduces the release of dopamine that occurs when people take nicotine and amphetamines. So it makes it more available, it modulates nicotinic receptors, but it also reduces the release of it. So what really makes things like amphetamines, crystal meth, or tobacco or cocaine enjoyable is that rush of dopamine that gets released when people take them. And so if you can prevent that massive release of dopamine, you're not going to enjoy it as much, so you don't get the high from it. So you smoke the cigarette, you get it takes the edge off a little bit, but it doesn't make you feel, that euphoric rush that people get from it, getting that reward mechanism. And so they've done some research studies in mice. I don't know if they've done it in humans yet or not, showing that when mice are given crystal meth or amphetamines, whatever amphetamine they're given, that giving Indian tobacco along with it seems to reduce the pleasure reward mechanism involved with these amphetamines. And that sort of suggests that maybe these might be useful for helping people with drug addictions. There was a human trial done decades ago for Indian tobacco given for smoking cessation. It didn't show benefit, but it may have been too small a trial. Maybe they didn't start it soon enough. I don't know what the mechanism. Maybe it doesn't work. I don't know. But I've used it with some patients for smoking cessation. It, works with some of them. Doesn't work with other people. And smoking's such a tricky one to get people off of because it just dependency and those habits of smoking are so deeply rooted that some people will have benefits by using Indian tobacco. Some people might benefit from the patch. Some people might benefit from the antidepressants. I do know that even substances like ayahuasca have been successful in getting people off drug addictions, including smoking and other amphetamines. So, there's lots of different ways, but we're just talking about lability right now. So that's how it works. I only really use it from practice primarily for as an expectorant for respiratory issues, and I don't use it that often. With regards to smoking cessation, I've used it a handful of times. Might help. Even the most successful drugs for smoking cessation probably don't work more than 50% of the time anyway. So, or even I'd say probably 20% of the time. Takes a lot of attempts to get people to stop addictions. So it works on dopamine, a little bit on serotonin, also modulates your nicotinic receptors as well. Now the next slide here is a picture of Socrates, and I took a Philosophy 101 course, and which I thought was kind of a fun, really interesting course. The big take home I took from it was that you can have so many really inspiring speakers that seem to know the quote unquote the truth, but then they all contradict each other. And you'll find that, like right now, I'm listening to all these books on nutrition and diet and reading or listening, mostly listening because I go to the gym, I listen to audiobooks. And it's amazing how they all are really convincing, and they all quote research that sounds really convincing, but in the end, a lot of these guys are contradicting each other, with regards to is meat good or is meat bad or is eggs good or is eggs bad, who knows, okay? Same thing with dairy. Anyways, going back to Socrates, he got himself into trouble because he was encouraging young or people in general to think for themselves, and this was kind of challenging authority, and the authorities didn't like that, so they executed him. The way they executed him is they gave him poison hemlock. And Plato wrote a little discourse describing his conversation with Socrates as he was being poisoned with the poison hemlock, and he describes how he's basically getting what's called ascending paralysis as well, where you first lose sensation in your feet and moves all the way up until it hits your respiratory tract or your heart, and you basically stop breathing and your heart will stop as well, okay? So that's what poison hemlock does. And now poison hemlock has conine in it, and this is basically a compound. It's a pyridine alkaloid, just like the ones we talked about earlier. And the way that it works is it blocks nicotinic receptors at the muscle junction. Okay, and so it basically causes ascending paralysis by preventing these nicotinic receptors from doing their thing. So I think initially what it does is actually stimulates them and then stays stuck in them so that it can't be re-stimulating again. So one of the things that often, it didn't really get portrayed in Plato's book, is that it will cause some initial GI distress like nausea and vomiting and diarrhea. But the ancient Greeks like to kind of elevate people like Socrates and other important people to like almost like a demigod-like state. So they didn't really go into the details of the nausea, vomiting, and the diarrhea aspect of it. But if you're preventing muscle contractions through blocking these nicotinic receptors, then eventually you'll die where your diaphragm and your heart just don't work anymore. Okay, and so conine, which is poison hemlock, grows in Europe. I don't think we have that here. We have other poisonous hemlock species here that are poisonous for other reasons. But that's how Conia maculatum basically acts as a poison, okay? Now, one of the things worth mentioning is that it looks an awful lot like celery, coriander, dill, cumin, because it's in the same family and it has the same seeds. So it would be easy to mistake this plant if you're like wild harvesting fennel or caraway. You could actually get poison hemlock and take it by mistake, okay? So there's also some local ones that are also look a lot like this that are poisonous hemlocks. They are toxic for other reasons. Be easy to mix those up as well. So be careful when you're gathering herbs that you know what you're doing, because there are some poisonous things out there you got to watch out for. So the take home here is Pyridine alkaloids. They have the potential to interact with nicotinic receptors. Okay, that's kind of what I'm wanting you to take home here. Conine does that, and so did the lobeline from Indian tobacco and poison hemlock. Okay, those two guys. Now, with regards to the nervous system, we talked about serotonin a little bit earlier, but going back to it again, serotonin is one of the important neurotransmitters in your body. Most people know it's a happy neurotransmitter, but your gut is full of serotonin receptors, and it's also involved with all sorts of different functions in your body. So skipping ahead here, mood is one aspect of it, but they play a role in vasoconstriction, vasodilation. Magic mushrooms and ayahuasca are involved with certain serotonin receptors in the body. Also peristalsis, so if you consume things that stimulate these serotonin receptors in your gut, it'll cause nausea, vomiting, and diarrhea. And so this is one of the reasons why things like ayahuasca or peyote, in addition to causing hallucinations, one of the side effects is often people will vomit after taking it and then eventually get diarrhea as it travels down through the system. And serotonin also modulates your body's temperature. So a lot of different things. So one reason why this is important to mention is that if you take too many things that affect serotonin in your body, like if you took an antidepressant drug and you combined it with maybe hallucinogen, that could potentially cause a fatal situation where you could get something called serotonin syndrome. Or if you were taking other things like 5-HTP, which is the natural supplement used to make serotonin, while someone's on an antidepressant, you could get serotonin syndrome. And that's basically where you overstimulate, you overheat, you get nausea, vomiting, diarrhea, you get all these muscle switches going on, there's all sorts of issues with the cardiovascular system, and rarely, but it could cause death. Okay? Now, the reason why I'm talking about serotonin is a class of alkaloids called indole alkaloids potentially can interact with serotonin receptors. So serotonin receptors, we'll talk about, because the indole group is found also in serotonin. So melatonin, serotonin, and dimethyltryptophan are all naturally occurring indole alkaloids in your body that either interact with serotonin or melatonin receptors. Okay. Now, reserpine is a important drug slash herb, originally from India. I've never been able to get a photograph of the plant. The herb is called Rolfia serpentina. So Rolfia has been used in the pharmaceutical realm for lowering blood. I've only used it once in practice. It was kind of falling into this gray area where it technically wasn't illegal to use it, but it just was flying under the radar of the regulatory bodies. I don't know what the legal status is right now. Where it worked was I had a patient that had unresponsive blood pressure. We couldn't get it down with anything else. And we gave them reserpine in a herb form, and it was able to dramatically lower blood pressure. And now one of the ways that this compound works is it has a few different types of alkaloids in here, but it does have this indole alkaloid, and it appears that it inhibits what's called vesicular monoamine transporters. And so what it does is normally when your neurotransmitters are reabsorbed into the nerve, they are basically stored in these vesicles so that they don't get broken down by the monoamine oxidase enzyme that's inside the cells. So this is kind of like putting your cattle or your sheep inside a fence so that coyotes won't get access to them, okay? So the coyotes like the monoamine oxidase enzyme. Now in this case, if you block the gate so that the neurotransmitters can't be taken back up by this monoamine transporter, then what ends up happening is you can't put them in the barn or in the or gate them in, so then they're exposed to the things that can attack them. Okay, so what ends up happening is you basically end up depleting epinephrine, norepinephrine, and dopamine, and also serotonin to some degree, and as a result, you decrease sympathetic tone. You decrease the effects of these neurotransmitters have, which can lower blood pressure, but you can also get some undesirable side effects of messing around with the other ones. So often people taking a lot of reserpine, you can lower the blood pressure, but you can also have depression. Now in India, they also used it for schizophrenia and other psychotic episodes because it depletes dopamine as well and serotonin that can have an effect on psychosis. So historically, it was used mainly for cardiovascular disease as a relaxant in small amounts, and then also for like blood pressure and mental health stuff. So that's one thing. Another interesting plant is ergotamine. Ergotamine, or it's not a plant, it's a compound from a fungus. So ergot fungus grows on moldy rye as well as some other grains. Ergotamine is a drug still used in medicine today, primarily for migraines because it acts as a very strong vasoconstrictor, and also for postpartum hemorrhages. So after a woman delivers her baby, if the uterine isn't contracting and stopping the blood flow and they're losing tons of blood, they'll give them a shot of ergotamine to cause basically the uterus to contract and also to cause vasoconstriction to prevent blood loss. Now, its mechanism of action is really complicated, but one of the main things that it basically does is binds to serotonin receptors in various parts of the body to cause that vasoconstriction and contraction of smooth muscles, okay? So for migraines, I wouldn't recommend using it, mainly because it has negative effects on the cardiovascular system. It can cause angina, elevated blood pressure. It can decrease blood flow. And so it can actually lead to gangrene of the fingers if it was used all the time. It also causes worsening of menstrual symptoms, causes nausea and vomiting. So really, really bad stuff. Now, the interesting story behind this is that ergot was studied by Albert Hofmann. He's a famous chemist in the 50s and 60s. And while extracting various indole alkaloids from ergot fungus, he accidentally extracted one compound called lysergic acid diethylamide that he spilt on his hand that diffused through his skin, and he started feeling funny, so he started biking home after that. He had basically this big drug trip because he was tripping out on LSD, and that was the first discovery of LSD or acid that was so popular in the 60s. And so LSD doesn't have the vasoconstricting effects and the negative effects on the uterus and cardiovascular system that the ergotamine has. It just seems to bind specifically to the serotonin receptors involved with hallucinations. And so appreciate there are all these different subtypes of serotonin and dopamine receptors in the body. Some of them are involved with nausea and vomiting. Some of them are involved with circulation. Some of them are involved with mood. Some are involved with hallucination. So depending on the subclass that you stimulate will have whatever effect, okay? So there are some historians who believe that maybe the witch hunts in Salem may have been encouraged because people were eating moldy rye bread that had a lot of ergot fungus growing on it, and as a result, people were getting some lysergic acid diethylamide in their diet along with some ergotamine, so they're hallucinating and people's fingers were rotting off, and maybe they're blaming witches that they were seeing in their visions. But it'd be kind of a fun historical reference to it. I don't know if it's accurate or not. There's some debate over that, but the take home here is both LSD and ergotamine are indole alkaloids that exert their mechanisms of action by stimulating serotonin receptors. So I think for exam purposes, serotonin receptors are related to indole alkaloids and hallucinations. And I might ask, ergotamine exerts its effect by working on what type of receptors in the body. It could have something like that. Now, dimethyltryptophan, this is a compound that's naturally occurring in the body. I think I've mentioned before, you release it when you have a near-death experience, when you're sleeping and you're dreaming. Several plants produce it, including this one called chacruna. This is one of the ingredients in the ayahuasca brews. Now, this stimulates certain serotonin receptors involved with hallucinations and also nausea and vomiting and diarrhea. But normally, if you were just to eat this plant alone, you probably would not have any effects because it's inactivated by the monoamine oxidase enzymes in your gut. These are the same ones that inactivate things like tyramine. So dimethyltryptophan taken orally normally is inactivated by it. Now in the Amazon, there's also some other plants that produce dimethyltryptophan, and instead of combining it with something that will inhibit the monoamine oxidase enzyme, sometimes they'll grind it up into a powder and blow it into the nostrils, and then it gets absorbed through the nose, and thereby bypassing the monoamine oxidase enzyme. So that's just a little side note. But chacruna taken orally will do very little. However, if you combine it with a harmyl alkaloid, it will exert some sort of effect. So harmyl alkaloids are found in the ayahuasca plant itself, which chacruna is mixed with to make the ayahuasca brew. It's also found in passion flowers, a little bit of tobacco as well. So passion flowers, I don't know precisely what kind of effect harmaline has on the system. One of the things that we do know that it does is it has some monoamine oxidase inhibiting effects. And so these harmaline alkaloids, which is a type of indole alkaloid, will inhibit this enzyme that breaks down things like tyramine and also dimethyltryptophan in your diet. So when people take dimethyltryptophan, it's normally broken down by the monoamine oxidase enzyme. However, if you take it with the harmaline, here you get that synergistic action we talked about that, is an example of it, where the two combined have a huge effect on the body, but one in isolation will have minimal effects. It might have some effects, like harmaline might still be responsible for some of the calming or nervine effects that passion flower has, but it's not going to have a huge effect. Now, one thing you have to watch out for is if you're taking things like ayahuasca or even passion flower, if you're drinking a lot of passion flower tea, it could potentially affect the absorption of tyramine. And so if you were doing a lot of this, you need to go on a special diet where you're not eating a lot of these fermented foods rich in tyramine. And that's one of the things with the shamans in South America. They know that you need to go on a special diet void of a number of things when you're planning on doing ayahuasca, so you don't have the tyramine getting into you. Which I don't know how they figured that one out. Avocado, just as an aside, I remember avocado does have some tyramine in it, but I do specifically remember when I was down the Amazon and I tried the ayahuasca that they were serving, at the place where I did it, they were serving avocado with one of the meals. So it must not have that significant effect on it. Jessica's asking if reserpine, sorry, I didn't see his question. What you asking here? So does reserpine act on monoamine oxidase enzyme? I don't know. That's not its main mechanism. The main mechanism for reserpine is this monoamine transporter, not the monoamine oxidase enzyme. It's primarily working on this transporter here. And the reason why it causes depression is because it basically depletes this reserpine, the reserpine depletes the various neurotransmitters because they are getting broken down by this enzyme here. How much passion flower tea would be considered long? I don't know, because I don't know how much harmaline's in it compared to ayahuasca. It's going to be dose dependent, so it may not even be possible to get enough from drinking tea, because I'd have to go and see if I can find how many parts per million or whatever is in passion flower versus ayahuasca, but I don't know. It's theoretical, and appreciate sometimes things that are theoretical are not, like, even though pharmacologically that mechanism exists, it may not be clinically significant. Just like, even though people give you that black box warning for grapefruit juice, you shouldn't combine it with Lipitor. Lots of people who take Lipitor drinks grapefruit juice every day and have no ill effects from doing that. Okay. Almost done the alkaloids. Pyrrolidine alkaloids. The most important thing you have to know about this is these are bad for your liver. Okay. Comfrey, which is a herb used by Western herbalists both internally and externally, is banned by Health Canada because it contains pyrrolidine alkaloids that basically damage the liver. Okay. Now, appreciate everything is dose dependent. So herbalists would use it internally, maybe for stomach ulcers and to help with inflammation of the gastrointestinal tract. Also, it's used topically for broken bones, bruises, arthritis. I would not recommend you take it internally, even though I think it's probably safe to take it for a week or two. But because of Health Canada's warning, if anything someone ever got a liver problem and they did some Googling, they found out that you get the comfrey, even though Health Canada basically has banned it for commercial use for internal purposes, you get in trouble. Now, we'll talk about this more when we talk about the safety, but lots of herbs have pyrrolidine alkaloids in it. It seems to be these unsaturated ones where they've got this double bond right over here. See the pink structure? That little double bond, that seems to make them hepatotoxic. Everything's dose dependent, so there are lots of herbs that, including echinacea, that contain pyrrolidine alkaloids that people take internally, but it's going to be a dose dependent thing, how much is in it and how frequently they take it. So the most important thing about the pyrrolidine alkaloids to take home is that comfrey contains it and that they can damage your liver. Okay, that's all I care about. You will learn about other herbs that contain them at some point as well. So borage, this is often used to make borage oil. It's kind of like even primrose oil. Colt's foot's used for coughs. It's consumed internally. It can be both smoked. Sometimes leaf is smoked for asthma, which is kind of ironic, but that's what historically was done. And tinctures can be made from it. Even in Chinese medicine, they use colt's foot for coughs as an expectorant and help with coughs. But it contains pyrrolidine alkaloids. Now, appreciate if you got a cough and you're taking this acutely for like an upper respiratory tract infection, you're not taking it for very long. So even if it did have pyrrolidine alkaloids, if you're taking it for a 2-week period, it's not going to hurt you. If you were taking it in high amounts every day for chronic asthma, I would be concerned that maybe you could get into that toxic sort of dose range, okay? Next compounds we're going to talk about are isoquinoline alkaloids. The isoquinoline alkaloids there's only a handful of the alkaloids that we talked about that are really going to come up in your practice. Isoquinoline alkaloids, these are a bunch of really important compounds, okay? You basically have 2 6-membered rings. You've got a pyridine ring attached to a benzene ring, basically. And depending on where that nitrogen group is attached to, if it's attached at basically at the 1 position, it's a quinoline alkaloid. If it's attached at the 2 position, it's an isoquinoline alkaloid, okay? Berberine, we've already talked about already. Berberine is found in golden seal, barberry, Oregon grape. A bunch of other herbs have it as well. There's some used in Chinese medicine. There's ones that grow different varieties or different species of barberry that grow in Asia and Central America or Middle East. But berberine, its main indication is a broad spectrum antimicrobial. And because it contains a nitrogen, you know, its main actions is not associated with the nervous system, but with protein synthesis. And one of the things that it does is it disrupts one of the enzymes involved with making RNA and DNA and proteins, okay? And that's an enzyme called sortase. And so this is an important antimicrobial. As I mentioned before, all these herbs have it, but they also contain another compound, that flavonolignin, that disrupts the multi-drug resistant pumps and helps the berberine act or function better, okay? Golden seal, one of my favorites, exclusively in Canada and I guess in the US as well. Barberry and Oregon grape. Oregon grape grows on the west coast. Barberry, we have different species that are growing wild now. They've been naturalized, but certainly originally it was in Western herbalism. Compounds working synergistically in the golden seal. Now, another important isoquinoline alkaloid is, there's two other ones that are interesting for historical reasons, but you won't use this in practice, is tuberculari. So curare is a plant that contains the drug tuberculin, which was once used as part of a mixture by indigenous people in Central and South America for hunting. So the old days when they had blow darts, and I think of the first Indiana Jones movie, and being chased by the guys with blow darts. Those darts, they used to basically put tuberculari on it. What it does is it blocks nicotinic receptors on the postsynaptic membrane, and that basically causes paralysis. And so if you were to drink tuberculari orally, you wouldn't have any effects. It wouldn't cause any paralysis in your muscles. But when you inject it or put it on a dart, it basically blocks acetylcholine from binding to the muscles, causes paralysis. So when they shoot, let's say, a bird or a monkey, it doesn't kill them right away. They just lose muscle function, then they're able to fall out of the tree. Now, they may still remain conscious. So it was once used in surgery to basically paralyze people so they could do surgery without having to move. The problem is you're paralyzed, but you're fully conscious of what's going on, so you may not be able to speak. You may not be able to move. So if the anesthetic wears off, you can still feel the pain. You just can't do anything about it. So it's kind of a bit creepy. So, so tuberculari has been replaced in medicine by other safer things now. But it is important from a historical standpoint. It'll come up in various TV shows and books and everything as well. So it's kind of a fun one to know. So basically at your muscles, you've got these nicotinic receptors that acetylcholine binds to allow the influx of sodium ions. It basically blocks that, so you can't get the muscle contraction to occur. Emmetine, this is another important one. So syrup of ipecac was historically found in every single pharmacy. I'm sure you can still find it now. Ipecac, here's a picture on the right-hand side. It grows in Central America. I took that in the herbarium in Costa Rica, I think. And syrup of ipecac, what it does is it stimulates emesis, which means vomiting. So they gave it to people who have taken some sort of poison, not caustic poisons like bleach, otherwise it burns on the way up as well. But if you overdose on pills, they would give you ipecac, make you vomit, pump out your stomach. And the way that it works, it basically stimulates, kind of like the Indian tobacco, but much stronger. It stimulates receptors involved with vomiting. Now, it was also historically used for treating certain types of parasitic infections. And so if you ate something that made you sick, you take a whole bunch of emmetine, basically you vomit, and then there's this antimicrobial effect. Not surprisingly, structure is a little bit like the things that you find in like golden seal and barberry, but because they're both isoquinoline alkaloids, but barberry and golden seal and Oregon grape don't cause vomiting. Okay. Quinoline alkaloids, not as important. I don't use them as often or ever. In medicine, I do like a gin and tonic from time to time. So quinine is your quinoline alkaloid. This is the antimalarial compound. It also has effects on the cardiovascular system where it can affect heart rhythm. So they do give it people with arrhythmia, so irregular heartbeats. It's a digestive bitter, just like berberine is. So you can you take your gin and tonic before a meal to stimulate your digestion. So the gin is rich with essential oils, so there's a carminative effect. The tonic water is your bitter. So that's your quinine molecule. Still an important building block for making various antimalarials, although this is rarely used as an antimalarial now. There's other versions of this, synthetic versions they've made. Quinine is sometimes used for ringing in the ears in cardiovascular systems, leg cramps, but there are some safety concerns taking that 9 months. The take home here is quinine is found in cinchona tree. This is the cinchona tree on the left. Took out a herb garden somewhere in South America. The world's first antimalarial. And if you remember when we were talking about in the first slide, it basically blocks this heme polymerase enzyme that's responsible for neutralizing toxic free heme and putting it into polymers called hemozoin. And by blocking that, you basically have more free heme around that's able to react with oxygen or peroxide in the body, generating free radicals causing death. So bringing a couple things that we talked about, the artemisinin, it can react to free heme. So if you combine quinine with artemisinin, it's going to work synergistically. And you know what? I bet you that 5-MHC that we talked about that's found in barberry, I bet you it's going to target some of these multi-drug resistant pumps that's responsible for drug resistance with a lot of quinine-based antimalarials. If I was going to do a master's, I would love to do it on this. Give people these methylquin or larium antimalarials along with multi-drug resistant pump inhibitors that are flavonoligand, and see if you could actually restore the antimalarial properties of quinine again to these drug resistant strains. So I might say, for an exam, quinine or quinoline alkaloids are known to have antimalarial properties. Oh, just as a side note, berberine does have some antimalarial properties as well that I've been looking at test tubes. I don't know if it was ever used historically for that purpose, but it does appear to have some of those effects too. So quinolizidine alkaloids, blue cohosh, this is used, it's a North American herb adopted by Western herbalism, but originally just used by First Nations people. It's used for menstrual issues, also a little bit involving child delivery, but I would not recommend you give it to patients who are pregnant. It does have some toxic effects. It does have an effect on the cardiovascular system. Both spartine and N-methylcysteine are involved, seem to have an antiarrhythmic effect. They target the heart. One of them was used historically for congestive heart failure and arrhythmias. It's also used as an emmenagogue to stimulate contraction of the uterus. Not a lot of questions on the exam on that. I'm not even sure what if I did ask any, but take home here, blue cohosh contains these compounds, and that's about it. Ben's got a question. Is that the same effect that Mullen has as well regarding anti-asthmatic? Mullen has different phytochemicals in it than colt's foot, so I don't think there's any issues with it. Mullen, I think, is pretty safe to take. It's used, so Mullen sometimes used in smoke mixtures. It has a demulcent effect, it has some antimicrobial effects. It does have a bit of a soothing effect. So if someone's, let's say, smoking medicinal marijuana, I'd rather have them mixing it with something like mullein, the herb verbascum, than using tobacco, which is addictive and carcinogenic. I don't think smoking anything is good for you, but mullein would be a lot safer for you than tobacco would be. Okay, last 5 organosulfur compounds. There's 2 main classes of these guys that are worth talking about. Okay, organosulfur compounds. What basically that means is you've got a sulfur compound in it, and it appears that a lot of the plants that have these sulfur-containing compounds exert some antimicrobial effects. They have some positive effects on antioxidant systems in the body. You know, when you hear about things like garlic, which has sulfur in it, and broccoli, Brussels sprouts, things like that, they all have been shown to have some beneficial effects on anti-cancer. They may have some neuroprotective effects, a whole bunch of things. So the 2 main families of plants that contain these are the brassica family, or cruciferous vegetables, broccoli, kale, rapini, arugula, things like that. And they contain glucosinolates in it, and also the onion family, which onions, garlic, scallions all have other types of garlic or sulfur-containing compounds in it as well. Now, just as an aside, cysteine and methionine contain sulfur-containing amino acids. Cysteine is used to make glutathione in the body. Methionine is a very important amino acid that is considered an essential amino acid for making proteins. But just as a side note, methionine deficient diets, which is what you're going to be getting if you're eating, avoiding animal products, and really limiting the amount of methionine that you get, may be involved with longevity. So animal products, one of the reasons why it's bad is because of the presence of methionine. So one of the reasons why animal products is good for you is because of the presence of methionine. So if you're trying to build muscle, methionine is good. If you're trying to not get cancer and heart disease, avoiding methionine is good. You know, it's one of those double-edged swords, you know. Now, the first one that I want to talk about are the compounds that are found in the brassica family, the cruciferous vegetables. Sulforaphane is the main compound that's biologically active, but it exists as a glycoside. And that's the glucosinolates, which is a bit of a mouthful. I didn't bother practicing how to pronounce these. So when you look at plants belonging to the brassica family, a lot of research studies show eating more of these vegetables is good for heart disease and cancer and a number of other things. Now, broccoli sprouts per gram gives you the highest amounts of these compared to any other member of the brassica family, okay? So you get almost 300 milligrams per about 24 grams, okay? I grabbed that from one study. The rest of these Brussels sprouts is way up there as well. Lots of these sulfur-containing compounds. As you go down the list, broccoli has some. So, you know, 44 grams of broccoli has only 27 grams. Broccoli sprouts, huge amounts, okay? Arugula I didn't find put on here, but I think arugula is actually really, really high in these as well. So if you want to get the health benefits, eating broccoli sprouts would be probably the most effective way to get them, okay? Now, there are different versions of it. So sulforaphane is the main compound in broccoli. There's another compound in arugula. There's a few different ones. Mustard has sinigrin in it. You can go and read the list of all these guys. So the compound on the left is the glycoside. The isothiocyanate is the active ingredient. And these guys get produced by enzymes that basically convert the glucosinolate into the isothiocyanate, okay? Now, little picture on the left here is broccoli sprouts. These are ones that I've grown myself. They're easy to do. If you want a simple, easy way to get broccoli sprouts is you go buy a bunch of seeds. I got mine off Amazon. And I basically soak the seeds overnight in water. The next day, pour them into I have a little tray I bought. I put a little bit of cheesecloth. You don't have to, but I like to put it in so I can dip it, just sort of wrap it underneath and dip it in water. And then you have to rinse it about 3 times a day. Don't put them on too thick, otherwise they'll go rotten. They'll start to smell really bad. If you don't rinse them and you put them on too thick, it smells like really bad, rotten, you know, sulfur, like really nasty sulfur stuff. So you got to rinse it every day. And after about 10 days, you get a nice little crop of broccoli sprouts. Another little trick I was reading, because I know that they contain sulfur, but sulfur is sometimes hard to get in your drinking water and in the soil. And unrelated, I did a little search because I know Epsom salts, which is magnesium sulfate, contains sulfur. I thought, I wonder if you add it to the water to have a positive effect. And I found some agricultural study in Australia where they found by adding magnesium sulfate to the soil, they're able to increase the isothiocyanates in their cruciferous vegetables, which is kind of neat. So I've tried that a few times. I can taste the difference if I add the magnesium sulfate. They have more of that pungent, sulfury taste to it. So it somehow is accumulating it from the magnesium sulfate, the Epsom salts. Plus, the Epsom salts may help with germination with magnesium as well. So the take home here is that these isothiocyanate compounds, the main one is the sulforaphane. It's unlike a whole bunch of the other phytochemicals that we talked about. It exerts anti-inflammatory effects, anti-cancer, anti-diabetic, has neuroprotective effects, helps protect your liver, helps with detoxification, lowers blood pressure, has antimicrobial effects. Like, they do everything. They're pretty awesome. Appreciate it. If you look at something like mustard, you can do a mustard seed plaster, where you take powdered mustard and you apply it to your skin. If you're not careful, you can burn yourself, because these things can actually give you a chemical burn if you overdo it. But you're not going to get that from just eating broccoli. Another concern with them is that they can act as goitrogen. So if you don't have enough iodine in your diet, you can bind up iodine and prevent the absorption and lead to a type of hypothyroidism. But I'm not really concerned about people in our culture who iodine's added to food and salt, so it shouldn't be an issue. I've never seen it be an issue for people. So even if you have hypothyroidism, I think you should eat your broccoli. The mechanism that these sulforaphane compounds work is through a whole bunch of different things. They can affect certain gene expressions in the body. They do a whole bunch of things. I don't even fully understand it. So I think these are probably one of the healthiest things you can do. I had a patient who came in with prostate cancer, heart disease, and diabetes. And I basically said, you should be growing your own broccoli sprouts or buying them, pre-grown, and eating this daily, because it will address all of his problems. The other thing that may have benefit for autism, there's a couple studies showing that it decreases some symptoms in autism. And autism there seems to be some weird sulfur metabolism issue with autism. So if you can recommend it, it's people whose children have autism, might give them some benefit as well. Now, if you've ever noticed eating cabbage, like sauerkraut, makes you go to the washroom, it can happen quite quickly. Eat sauerkraut, everyone's going to the washroom, having lots of bowel movements. I always assumed it was because of the probiotics in it. But the compounds, these same compounds in cabbage, the way they work is they bind to something called enterochromaffin cells in the gut. And these are normally responsible for detecting some kind of dietary irritants. And they also, serotonin is involved with this process as well. And so when you bind things to this, it causes the release of serotonin that increases peristalsis in the gut. So eating cabbage or broccoli or Brussels sprouts or sauerkraut, those are all strategies to increase bowel movements in people as well. So cabbage juice, the only big issue with it is that it can give you really bad smelling gas flatulence, so gotta watch that. And there are lots of studies showing it decreases mortality with people eating a lot of cruciferous vegetables. And I would say that's going to be dose dependent. So they see some benefit, but I bet you if you were to take things like broccoli sprouts that are really high in these, you're going to get an even better effect. Now, garlic also has sulfur-containing compounds. Allicin is one of the compounds that first gets released when garlic is pressed. So raw, unprocessed garlic contains allicin, and this compound, when you crush it, releases an enzyme called allicinase that basically forms allicin. This compound here is easily oxidized And so when it becomes oxidized, you get a volatile oil, and ijoine is another compound that gets basically is a condensed product of allicin. Now, garlic has two main functions in the body as an antimicrobial, and primarily allicin, I think I pronounced it correctly, it seems to be the main antimicrobial, and the fermented garlic products that are often recommended for heart disease contain higher amounts of this ogene products in it. And I think that any kind of garlic product is probably going to have a positive effect on blood pressure and cholesterol, but most of the research is done with fermented ones. Now, oxidized, eventually allicin, if you take it orally, it will become oxidized in the body as well. So for garlic, the take-home thing is allicin supplements. There's one particular brand on the market that I know of that somehow has been able to preserve the allicin molecule without having it get oxidized. And it's useful for various types of infections, colds and flus, and also dysbiosis in the gut. And then fermented products, there's one called like Kylock, for example. They've done a lot of research on PubMed that uses their products to test for the benefits for as a blood thinner, for lowering cholesterol, for cardiovascular events and stuff like that. I got a couple questions here. Do you know if you have to eat cruciferous vegetables raw to get the sulforaphane? I think it's better eating it raw. I think broccoli sprouts. I know with broccoli sprouts, in order to get, there's a good little YouTube video I watched done by a researcher. This enzyme reaction that converts the glucosinolates to the isothiocyanates involves an enzyme that if you have your broccoli sprouts and you add hot water, like I think it's around 80 degrees to it, but not 100 degrees, then it stimulates the enzyme to do its job and helps perform more of the sulforaphanes to get them to break down and to liberate them. And that'll give you, make it more bioavailable. So some heat is good to activate the enzymes and to break up the cell structure and stuff, but then too much will inactivate the enzymes and you won't get as much of the conversion that you want. So I think eating them raw is good, and I think if you really want to get the best bang for your buck, if you want to grow them yourself, add a little Epsom salts to increase the amount of the isothiocyanates that are being produced, and then a little bit of heat can help to liberate the enzymes, but too much heat might actually reduce it. So, I think there's still benefits of eating cooked broccoli, but overcooking it may not be a good idea. What about, Allison's asking, what about them improves ASD symptoms? I don't know anything about ASD symptoms and sulforaphane. So that's new to me. 12 o'clock, went over a little bit. What I'm going to do, so just pretty quickly, if you're getting kicked out of the classroom, sorry about this, but I'll post this. Midterm, 73 questions. I wanted to have 75, but I couldn't because of I didn't have enough. There'll be some sample questions on this little handout I'm going to post. Which of the following books was written by blank? So that might be a question I would ask on the intro lectures. The intro lecture had two sections. It had the pharmacology questions and the history questions, okay? Which system of medicine, talked about the four humors or whatever it may be. You can read all these. Some questions about drugs, the various drug questions, a whole bunch of things on phytochemicals. So please go through this because you'll get an idea of the types of questions I'm going to ask for. And I think if you can answer all these, you're going to do pretty good on the exam. And I'm not going to go into too much detail, but there's still a lot of stuff you guys need to know. Do you have any questions? Any questions? Sorry, I didn't hear you about autism symptoms. Oh, what did you ask? Oh, I don't know what symptoms, I think precisely. Sorry, ASD, autism, I didn't realize it. The acronym for autism, because I don't really treat a lot of autism. I don't remember. I watched the little documentary or the research thing a while ago and talked about autism. I can't remember what precise symptoms, but we can easily look it up because I'm curious. Maybe like social activity. I don't know. Autism and Sephora. Okay, did I get that right? Oops, not page. I don't know if I'll be able to find it quickly or not. Symptoms of autism. This is a case study, but they had some other ones. Doesn't really say in this one. I don't know. I'm sure you can find it. Sorry about that, but I didn't really look into it a lot. I don't treat autism in practice, frankly. Yeah, can't find it, but anyways. If you want, I'll post a little, if you want to look at that, you don't have to, but if you want to look at a little YouTube video, it's quite good on the sulforaphane summary. Okay, if you guys don't have any questions, have a great week. See you back in a couple weeks now. You got off, so enjoy your time off. That sounds awesome. And I hope you guys do great on the exam. If you have any questions, post them on the forum and also email me as well to tell me you posted a question on the forum. And I'll make sure that I check that periodically. Okay? Thanks, guys. Bye for now.